Hope you are well and doing well at home. Stay safe, stay home. So today we will study about fluid mechanics and most important questions about fluid mechanics, which are important for your GATE exams, TEST exams, and other competitive exams. So fluid mechanics subjects is most important in every field because it involves the study of behavior of fluid in motion or in rest. So we study different questions related to fluid mechanics which are important for your viva also in fluid mechanics lab, and they are also important for MCQs, multi choice questions, and other exams also. So let's start because some students demands about the fluid mechanics questions. So there are some important questions related to fluid mechanics, so you may find a good knowledgeable questions by watching this video. Okay, so we can start with fluid. So fluid mechanics involves two words. Basically one is fluid and second one is mechanics. So students, what is fluid? So first we describe the fluid. What is fluid? A fluid is a substance that is capable of flowing. Okay, so fluid is a substance that is capable of flowing, deform continuously when it is subjected to even smallest shear stress, and it deforms continuously when it is subjected to smallest shear stress. Okay, so liquid involves fluid and gases, and if we discuss about the liquid, then liquid involves both. Liquid involves both fluid and gases. Okay, so next is fluid mechanics. And fluid mechanics, what is fluid mechanics? And fluid mechanics study the behavior of fluid at rest and in motion. So we can say that it may be defined as study of behavior of fluid at rest and in motion is known as fluid mechanics. So third one is kinematics of fluid. So fluid mechanics is further divided in kinematics of fluid and dynamics of fluids. So first is kinematics of fluid, study of fluid in motion without considering the force that causes motion. So kinematic of fluid related to fluid in motion without considering the force that causes motion. And dynamics of fluid, study of fluid in motion considering the force that causes motion. So both are different, kinematics and dynamics. Kinematics involves study of fluid in motion without considering the force that causes motion. And in dynamics of fluid, study of fluid in motion considering the forces that cause motion also. Okay, so I hope you may understand. Next is ideal fluid. So students, you know that fluids are of different types. Okay, so first one is ideal fluid. Ideal fluid is a imaginary fluid. Okay, and it is frictionless and incompressible. So it is a imaginary fluid, it is frictionless and incompressible and has no viscosity. Okay, it has no viscosity. And next one is real fluid. Real fluid, as you know, that is real one. These fluids are compressible in nature and all the fluids are real and has viscosity. So all the fluids in the universe are real and has viscosity. Okay, next one is Newtonian fluid. When the fluid obeys Newton's law of viscosity is known as Newtonian fluid. And non-Newtonian fluids, when the fluid does not obey Newton's law of viscosity, are known as non-Newtonian fluid. Further, we will also discuss about the Newton law of viscosity. So you may get the better understanding about the Newton law of viscosity as well as Newtonian fluids. Okay, and we will also discuss later in our session about the viscosity, kinetic viscosity. So you may get the better idea about these terms. So I will repeat again. Fluid is a substance that is capable of flowing. Fluid mechanics, study of behavior of fluid at rest in motion. Kinetic of fluid, study of fluid in motion without considering the force that causes motion. Dynamic of fluid, study of fluid in motion considering the force that causes motion. Ideal fluid, it is frictionless and incompressible and has no viscosity. And real fluid, these fluids are compressible in nature, and all the fluids are real and has viscosity. Newtonian fluid, which obey Newton's law of viscosity. Non-Newtonian fluid, when fluid does not obey Newton's law of viscosity. Next is ideal plastic fluid. When shear stress is okay, when shear stress is proportional to velocity gradient and shear stress is more than the yield value. Shear stress is more than the yield value. That type of fluid is known as ideal plastic fluid. Next is incompressible fluid, when the density of fluid does not change. Okay, when the density of fluid does not change with application of external force is known as incompressible fluid. When we apply external force on the fluid, then their density not change. That type of fluid is known as incompressible fluid. Next is compressible fluid. When density of fluid changes with application of external force, that is known as compressible fluid. When density changes by applying the external force, that type of fluid are known as compressible fluid. Next is Newton's law of viscosity. So students, you know that Newtonian fluid about the and non-Newtonian fluid. So Newtonian fluid obeys the Newton law of viscosity, and non-Newtonian fluid do not obey Newton law of viscosity. So what is Newton law of viscosity? It states that shear stress is directly proportional to rate of shear strain, or we can say that velocity gradient. Shear stress is directly proportional to rate of shear strain or velocity gradient. And we can say that shear stress is equal to mu du by dx, where mu is coefficient of viscosity and du by dx is velocity gradient or rate of shear strain. And it is 0 for fluid at rest. If fluid is not flowing, then velocity gradient is 0 in that case. Next, what is velocity gradient? Okay, so velocity gradient is change of velocity between two adjacent fluid layers divided by the distance between the layers. So in simple way, we can say that velocity gradient is a value, or is that value that shows us about the change of velocity between the two layers of fluid. So you know that when fluid flows in a pipe, that the fluid flow in a layers. Okay, one layer, then below that other layer, then below that other layer. So fluid flow in a layers. Okay, and the different distance between one layer to next layer is the distance between these two layers. So velocity gradient is that change of velocity between two adjacent fluid layers. So what is the change between these two adjacent velocities? If the first layer velocity is 10 and other layer velocity is 11, so difference between these two velocities is 1. Okay, so change of velocity between two adjacent fluid layers divided by distance between the layers is known as velocity gradient. Next is hydrostatic law. It states that rate of increase of pressure in vertically downward direction is equal to specific weight of fluid. Okay, that means increase in pressure in the vertically downward direction is equal to specific weight of fluid. So rate of increase of pressure in vertically downward direction is denoted by dp by dz and is equal to specific weight, that means W, and W is equal to rho into G. Specific weight is equal to density into gravity. Next is absolute pressure. So this question is asked many times in Viva about the what is absolute pressure, what is gauge pressure, and this is most important for fluid mechanics Viva questions lab के लिए. So absolute pressure, if the pressure measured from absolute zero pressure. Okay, if the pressure measured from absolute zero pressure, or we can say that pressure measured from a reference, take reference value at from absolute zero. Okay, that means we don't consider the atmospheric pressure. In that case, we consider absolute zero. We have measured the pressure from absolute zero to up to the pressure of the vacuum. Similarly, gauge pressure, it is measured with reference to atmospheric pressure. So gauge pressure, consider the atmospheric pressure. Okay, it start measuring pressure from atmospheric pressure and above, that is gauge pressure. Vacuum pressure, the pressure below atmospheric pressure. So the pressure below atmospheric pressure is known as vacuum pressure. So I again repeat, what is absolute pressure? When we measure a pressure from absolute zero to the exact value, and when we measure the gauge pressure from the atmospheric pressure to the next value, and when we measure the pressure below the atmospheric pressure, that is vacuum pressure. So formula for gauge pressure is equal to absolute pressure minus atmospheric pressure. If we subtract absolute pressure minus atmospheric pressure, we will get gauge pressure, because you know that absolute pressure gives you gauge pressure. Okay, similarly vacuum pressure is equal to atmospheric pressure minus absolute pressure. So this condition satisfied the above definitions. Next is viscosity. So students, viscosity, you know that what is viscosity. Viscosity provide resistance to the movement of one layer of fluid over the another adjacent layer of fluid. So if fluid moving from one place to other place, and the fluid moving in a layers, then the what viscosity do? Viscosity provide resistance to the flowing of the layers of fluid. Okay, so which offers resistance to the movement of one layer of fluid over another adjacent layer of fluid is known as viscosity. So we can say that in a simple way, which provide resistance to the movement of layer of fluids are known as viscosity. Next is kinematics. Kinematic viscosity, or we can say that kinematic viscosity is a ratio of absolute or dynamic viscosity to the density of fluid. Absolute viscosity or dynamic viscosity to the density of fluid, and its CGS unit is stroke centimeter square divided by second. It is independent of pressure and depends upon temperature. So viscosity independent of pressure and it depends on temperature. If temperature increase, then movement increase. Okay, if temperature decrease, movement decrease of fluid. Next is compressibility. So what is compressibility? It is reciprocal of bulk modulus of elasticity. We can say that compressibility is equal to 1 by bulk modulus. And bulk modulus is defined as compressive stress to the volumetric strain. What is bulk modulus of elasticity? Bulk modulus of elasticity is equal to compressive stress to the volumetric strain. Next is surface tension. Next definition, what is surface tension? So it is defined as tensile force acting on the surface of liquid. Tensile force acting on the surface of liquid with a gas such that contact surface behaves like a membrane. Contact surface behaves like a membrane under tension. It is expressed as force per unit length. So surface tension may be expressed in the form of force per unit length. Next is capillarity. The phenomena of rising or fall of liquid in a small vertical tube held in liquid relative to journal level of liquid. So what is capillarity? So for example, you take a water in a bucket or in a, we can say that a jar, and you put a vertical tube in that jar or in that bucket, then water fills in the tube and water go upside. So that process is known as capillarity. The phenomena of rising or fall of liquid. So when we put tube in the bucket and the water level go up and down, that process is known as capillarity about the journal level. The phenomena of rising or fall of liquid in a small vertical tube held in liquid relative to journal level of liquid. So how we can measure capillarity? So formula for measuring capillarity, H is equal to 4 sigma cos alpha divided by W dot D, where H is capillary height, alpha is angle of contact of water surface, sigma is force of surface tension. Next definition is Pascal's law. So what is Pascal law? So the Pascal law is most important from the 11th 12th. Okay. So this may ask many times and during our studies. So what is Pascal law? The intensity of pressure at any point. The intensity of pressure at any point in a fluid at rest is same in all directions. When fluid is not moving or fluid is at rest, at that time the intensity of pressure at any point is same. Okay, that is known as Pascal law. We can say we can again say that the intensity of pressure at any point in a fluid at rest is same in all direction are known as Pascal law. Next one is cavitation. Okay, so it is formation of bubbles or cavity. What is cavitation? It is formation of bubbles or cavity in liquid developed in area of low pressure. So it developed in area of low pressure, that is known as cavity. Next is buoyant force, and we can say that buoyancy. When we submerge a body or object in water, then water displaces against the body, against that body area. Okay, that process is known as buoyant. Or we can say that the water react about that body and opposes the pressure of that object. Okay, we can say that it is the resultant force exerted on a body by a static fluid in which it's submerged or floating. So by buoyant force is that force that exerted on a body by a static fluid in which it's submerged or floating. Okay, that is known as buoyant force. So we can say that in the form of when we submerged or when we put a object on static water, the water is at rest, then that static water exert a force on that body. Okay, exert a force on that body. That force is known as buoyant force. Next is center of buoyancy. It acts through centroid of displaced volume of fluid. It holds good for both submerged and floating body. Okay, so the center of buoyancy means it acts through the point. Okay, it act the force act through a point. That point is known as center of buoyancy. Next is metacenter. It is the point where buoyant force and center line intersects. Metacenter is that point where buoyant force and center line intersect. If center line and buoyant force point is intersects, that point is known as metacenter. Next one is distance between M and G. You know that what is M? M is metacenter, G is center of gravity. Okay, and the distance between M and G is known as metacentric height. The distance between metacenter and center of gravity is known as metacentric height. Next is discharge. What is discharge? You know that discharge from a tank, discharge from a boiler, discharge from a orifice, discharge from any type of object. How we can measure discharge? Volume of water flow. So volume of water flow through a section or pipe per second is known as discharge. Volume of water flow through a section or pipe per second is known as discharge. Next is types of flows. Okay, we can discuss about the types of flows in fluid mechanics. So first is uniform flow. If the velocity of liquid particles at all sections of pipe or channel are equal, we can say that if water is flowing in a pipe or channel and velocity are same in the whole pipe or in whole section, that flow is known as uniform flow. Second is non-uniform flow. If velocity of the liquid in all sections or pipe is not equal, that is known as non-uniform flow. Steady flow, the flow in which quantity of liquid flowing per second is constant, is called steady flow. That means quantity of liquid is flowing per second is constant. That means quantity of water is same or flowing per second is same. That is known as steady flow. And unsteady flow, when quantity of liquid flowing per second is not constant, is called unsteady flow. Next is laminar flow. The flow in which path of individual particles of liquid do not cross each other is called streamline or laminar flow. We can say that if the fluid flows and layers of fluid don't cross each other, that flow is known as laminar flow. And if the layers of fluid cross each other, that flow is known as turbulent flow. In laminar flow, Reynolds number is less than 2000, and in turbulent flow, Reynolds number is more than 4000. And between 2000 to 4000, that is known as transition phase. According to Reynolds, the transition from laminar to turbulent flow depends upon velocity, pipe diameter, and kinetic viscosity. Next is kinematic viscosity. So it is also discussed earlier in the last slide. So we again look after it. Kinetic viscosity, it is a measure of fluid internal resistance. It is a measure of fluid internal resistance to flow under gravitational force. So what is kinetic viscosity? Which measure the internal resistance of fluid. We can say that kinetic viscosity is a viscosity which measures internal resistance of fluid during flowing, okay, or under the gravitational force. So kinetic viscosity is a measure of fluid internal resistance and under the gravitational force. That process is known as kinematic viscosity. That is continuity equation. Next one is continuity equation. So what is continuity equation? It states that rate at which mass enters the system is equal to rate at which mass leaves the system. So continuity equation is states that the rate of mass of fluid enters at a system is equal to rate of mass of fluid leaves at the system plus accumulation of mass within the system. That process is known as continuity process, and it is good for incompressible fluid only. Okay, this equation is good for incompressible fluid. Or we can say that it is stated that rate at which mass enters a system is equal to rate at which mass leaves the system, or Q is equal to A1 V1 is equal to A2 V2. A1 is a area, V1 is a velocity. Okay. Similarly, A1 is a area for one point, V1 is also velocity at one point, A2 is a area at other point, V2 is a velocity at other point, and where Q is a discharge. Okay. So these both the points are equal, that satisfies the continuity equation. Next is Bernoulli's equation. So it is a general equation that describes the pressure difference. So it describes the pressure difference in two different points of pipe. So basically Bernoulli equation describes about the pressure difference in two different points of pipe with respect to velocity change. With respect to velocity change or change in kinetic energy, and height change or change in potential energy. So next is total head. Total head is the sum of potential head, kinetic head, and pressure head. What is total head? Total head is equal to sum of potential head, kinetic head, and pressure head of liquid particles. Next one is dimensionless parameters. So in fluid mechanics there are few dimensionless parameters also. One is Reynolds number, which is equal to inertial force divided by viscous force, and formula for Reynolds number is rho Vd divided by mu, where rho is density, V is velocity, and D is diameter, and mu is coefficient of friction. Froude number, dynamic force divided by weight. Weber number, inertial force divided by surface tension force. Next is Mach number, inertial force divided by elastic force. Next is notch, used for measuring the rate of flow of liquid through a small channel. So notch is used for measuring the rate of flow of liquid through a small channel. And Darcy equation is used for measuring energy loss. Darcy equation is used for measuring energy loss through friction in pipeline. Next is density or mass density. Basically, everyone know about the density, but you don't hear about mass density. So density and mass density both are same. So Density is equal to mass of fluid divided by volume of fluid. And what is weight density? So weight density and specific weight are of same. Both the term are same. Weight density and specific weight. If someone asks about the specific weight, then you can memorize your weight density. So both the term are same. Weight density and specific weight. That is equal to weight of fluid divided by volume of fluid. And what is weight of fluid? Weight of fluid is equal to mass of fluid multiplied by gravitational force divided by volume of fluid. Okay. Next is specific volume. It is defined as volume per unit mass, or it is the reciprocal of mass density. Specific volume is the reciprocal of mass density and it is equal to volume divided by mass. Next is specific gravity. Weight density or mass density of fluid to the weight density or mass density of standard fluid. So specific gravity is the ratio of weight density or mass density of fluid to the weight density or mass density of standard fluid. So we can say that for liquid water is the standard fluid, or for gases air is the standard fluid. Okay, for liquid water is the standard fluid at 4 degrees Celsius, and for gases air is the taken as the standard fluid. So these are the few important questions about fluid mechanics, and in the next session we also take important questions from engineering mechanics, and after that we can go for further subjects. So by session we cover up all the engineering subjects from mechanical engineering department, and you may find good application in your interviews as well as your competitive exams. Till then, thank you. Keep learning, keep enhancing your knowledge, keep watching.